Hey, hi guys, this is Akash. So we are going to be starting the stream at probably 10 o'clock. We still have 15 minutes to go. So till then, we are just doing a little bit of testing. And if you guys are around, just drop in to say hi or drop in to say a question if you have. Till then, I'm just okay. I'm just trying to check if the stream is working all right, and if there are people who have joined. If not, we are probably going to be just. If Okay, there's just two people. We probably need to wait for more people to join in, and I can see that I'm very clearly visible and my screen is available. Let's just do a test of screen sharing for myself. Okay, that's good enough. Whiteboard, good enough. Okay, so we'll be starting the stream at 10. This is just more of doing initial mic testing just 15 minutes before. I can see that things are working fine. Guys, if you can drop in the name in your chat, it would help me to see who and who's there. Hey guys. Okay. Oh, interesting. Now there are 4 people watching. Hello, everyone. Whomsoever, if you can drop in your name in the chat, that would be good. We are going to formally start in 5 minutes. But if there's a specific area in cloud which you want to talk about, just drop in the chat and we'll probably try to talk about it. Okay. Hey, hi KP, how are you? Good to see you here. This is interesting. We will formally start in 5-7 minutes. Very few things that you probably don't know, but let's see. Hey everyone, hello, hi. Good to see you. Nice name that you have, Mystery K. That's quite interesting. Feel free to get in your friends, people. We are going to be talking about cloud and how cloud works, and we'll take a hands-on approach to starting with the cloud. We'll also talk about some technologies like, or rather technologies, some terms like infrastructure as a service, platform as a service. Hey, hello Priyambada. Hello, how are you? Good evening. Good evening. Thank you for joining in. Thank you. It means a lot that you're joining in. Just pull in your friends. We'll probably be starting in 5-7 more minutes. If there's anything specific that you want to talk about or learn till then, just drop in your comments. And to give you a sneak peek, what we'll be talking about, just to see my screen, we'll touch upon these terms. What is on premises? What is infrastructure as a service? Platform as a service? Software as a service? And then we are going to go on to DigitalOcean Cloud, kind of try and look at what almost every cloud provider has to offer. And we'll show the same thing in AWS and maybe even Google Cloud, sorry, Microsoft Cloud if possible. So yeah, that's what we will be talking about. So just allow me 2-3 more minutes and we will start. Thank you. Till then, I'm just muting myself. We'll see how many folks are joining in. People in chat, if you have something to talk about, if you want to shoot a question, feel free to do that. Is my audio clear, by the way, to everyone? Just a quick check. Okay, thanks, KP. If it is clear, thank you. Okay, thanks, KP. If it is clear. Sorry, there was Anika. I was trying to play the stream at the same time, talk with the system. Okay, so let's see. There's a question. I'll try to check the question. Just allow me a moment, Priyamvada. Just trying to see the question. Allow me a moment. Okay, I have one project in which you want to access the contacts of people through Python. Okay, it is possible, though this is not related to cloud. I would say that the way to go about it is if you're working on an Android project, what you can do is use Android built-in APIs, and there is a way which you can access contacts if the user gives you permissions. So you will have to work with Android SDK and figure out a way to connect to Android Resource Manager, and that should get you access to contacts, provided the person has granted you permissions to access contacts. If the person refuses, then you would not be able to. This is less of a Python problem, more of a app development problem, be it Android or iOS, if that helps. All right, all right. I don't see more people chipping in. Let's begin. All right, so we will start with the basics. We'll just start with some definitions, and what we are going to cover today, just to set objectives of the session, is we'll talk about cloud, what it is, the purpose cloud solves currently. We'll look at terms like infrastructure as a service, platform as a service, software as a service. What are they different about, and what they really mean, and what they mean to you, right? When you're all working towards a problem, how do you decide what to select? And these are just terms which are thrown around, but we'll just take a slightly more deeper dive into that. Then we are going to be looking at a cloud provider specifically and see what type of services cloud has to offer, and then probably demonstrate a simple example of maybe creating a virtual machine and showing you how storage services are created and things like that. And then we could probably take questions at the end, or you can just keep throwing questions and I could take that simultaneously as well. All right, so we will begin. Now, this is a formal definition of cloud computing. Wikipedia defines it as on-demand availability of computer science or computer system resources, right? The way I tend to think of cloud is very similar to good old cyber cafes, right? I did not start my life with a computer. I probably got that when I was in 8th standard. So before that, every time I needed to access a computer, be it to access an email, print out report cards, book a ticket, and things like that in those old days, I used to go to a cyber cafe. Now, cyber cafe is a place where a lot of infrastructure or a lot of computers were kept, and you can use them pay by the hour, right? That's loosely what is cloud for me. Just trying to give a very simpler example there. So what it means is there's an on-demand availability of computer system resources. Now, what are these resources? We'll quickly take a look. Right. So when we talk of cloud, right, there's few terms that come to our mind. The first is compute, and compute really means the servers. All right, the EC2 instances, as some of you might know. This is where things run. Then we need storage, and by storage we mean, let's say, simple disks. There's other forms of storages. For instance, you have S3 buckets, you have databases, you have NoSQL databases, and there's probably file systems also, right? There's files and all those things. So these are the two basic things, right? Compute, and when we say compute, we typically mean two things again. We mean CPU and we mean memory, right? When we talk about this is what makes a computer system, right? In general, from a user perspective. So compute and storage. Compute implies CPU and memory, and storage implies all the different ways of storing information. However, there's a lot of other things that we probably do not pay attention to when we use a computer, but that is critical. For instance, network, right? We all just assume that we are connected to a Wi-Fi or a LAN cable and network is available. However, on cloud, networking becomes a critical piece, right? So we need to worry about networking on cloud, which is to say how X cloud resource versus Y cloud resource are connected together. It is also important to understand from a networking perspective how you as a user are accessing something which is somewhere else, and this is internet, and you are able to access this, right? So this is network. So networking is a very, very critical part of cloud. And when we talk networking, we typically talk about things like load balancers. We typically talk about actual networks like virtual networks. So this is the third component, right? So this compute, again, to re-emphasize, we talk about compute, we talk about storage, and we talk about network. Now, a combination of these three things is what allows people to access computer system resources, which is systems, right? Which is infrastructure services at the very base. Couple of few additional parameters to understand when we talk about cloud, right? While we have discussed there are three things, another important concept to understand here is the physical nature of machines versus virtual. Now, what does virtual mean? If some of you have used things like VirtualBox, you would know that there's a concept called virtualization, right? And what virtualization happens is, what virtualization does is, there's a machine which is usually called as bare metal. On top of it, there is a virtualization software installed, which effectively allows this large machine to be sliced into smaller chunks. Let's say chunk 1, chunk 2, chunk 3. And you can install different operating systems on each of them, right? This is what is the most basic form of virtualization. And this is effectively what powers most of the computing infrastructure that we have access to. So I would say it is, just to re-emphasize, it is compute, it is disks or storage, whatever you want to call, these networking, and another powerful aspect is virtualization, right? It is important to understand these four in a stack so that you can probably think of them as a stack, as a stack, I would say, and that would enable you to kind of go about building systems on it or building applications on it. All right. So that's pretty much what sums up a high level background on cloud. All right. I would now go back and show you an image which will probably talk about the same thing in a slightly more detailed fashion. All right. So when we have a setup, right, we'll start from left and go towards right. Now, when you have something on premises, the usual term on premises refers to a data center. What is a data center? It is effectively a large building or a warehouse where a lot of servers are kept, and it has almost everything. This is true for big organization where they have their own proprietary, or they own the hardware. It's basically saying that if I create, if I have this room where I'm sitting, and if I put on like 10 machines, it would imply that I'm running a small data center for my own. Though that would be a kind of a stupid term to call out, but that pretty much in some essence is sorry, my bad, I'm accidental clicks should be better now, sorry about that. Yeah, so on-premise is effectively infrastructure which these organizations own, and it is their, everything that they have is lying with them. All right. So at the very bottom of the stack, what you see here is you manage, which means this is managed by you. And the keyword which I talked about in the beginning, right? Which is somewhere here. Again, just to re-emphasize, cloud, disk, network, and virtualization. We'll have to remember this so as to be able to build on it. So if you see here, we are talking of networking, which is all the communication between all of the different hardware components, the storage, which is the storage. And why is networking below? Because even these storage devices are connected together, right? Think about it in a way that if you have a USB hub at home, right, you connect them, right? You connect one hard disk, one pen drive, maybe a dongle, maybe some kind of a, I don't know, a different adapter and things like that. All of these are connected. So that connected nature is what is you can think of as networking. On top or enabled by networking more so is storage. Storage is disks, because even servers would need storages to kind of have some sort of installation or have things where we are kind of setting up. Hey guys, I can see that there are people increasing. Thank you for chipping in. People who have joined just now, we have just started. We are talking about infrastructure and how cloud works, and we're just touching and beginning the session. If you have some questions about cloud, please put in the chat, and I'll try my best to address it. All right. So storage, servers, and on top you have virtualization, and on top of it you have operating system. Then some kind of middleware. A middleware, you can think of a software which does some sort of mediation, right? A good example of a middleware in data science world would be maybe CUDA, or even CUDA is a runtime. So middleware slash runtime, there could be, from an OS perspective, service buses are what a good example of middleware. Runtime would be Python runtime, Java runtime, things like that. And on top of it is data and application. Okay, this is crucial to understand. If you want to build your own setup, you are in the green zone. All of these are something you manage. What does management mean? It means you're responsible for them. All sorts of upgrade, all sorts of failures, power issues, heating issues, uh, cooling issues, access issues, physical security, and all sorts of good words out there. Then from this, we kind of move to this side, right? Infrastructure as a service. And this is where cloud starts. This is where the world as we understand in the computing sense, that starts. All right. So with infrastructure as a service on cloud, you have networking, storage, servers, and virtualization managed by cloud provider. All you need to do is worry about your OS, worry about middleware, runtime, data, and application. And I'll show you an example of what a infrastructure as a service is when we talk about DigitalOcean Cloud. All right, that's infrastructure as a service. The benefit is you don't have to take care of anything physical, right? You're pretty much not at all responsible for managing and maintaining, let's say, power, managing and maintaining cooling and things like that. Just a second. All right. Now we'll move on to another term, which is platform as a service. Now, what happens is most of the times people are not interested in even worrying about things like runtime engines or operating systems, because even then you have to worry about OS upgrades, framework upgrades like Python version upgraded. What do I do? Right? Or Java version upgraded, things like that. So you don't want to take care of that. You want some place where you just want to worry about your code, and you just want to have users do it, believe in it, right? Users access it. So this is typically where most of the people, providers like what is there's a very popular one, Heroku play, right? You have, they give you a platform as a service which is ready to use. Then you have the final nirvana state, right? Software as a service, where you just use something. For example, YouTube is a software as a service. While, yeah, it falls under a different category of platform or systems, YouTube is software as a service. What software as a service implies is you just use and consume it. You effectively become the consumer. Your relationship is not there as a provider. And on cloud, the example would be all the APIs that these Google Cloud providers or Azure provides. Now, what I'm going to do is I'll start from right to left and show the varying degrees of complexity that you have with each of them, right? So we'll start with software as a service, and I'm just going to take Google Cloud NLP API. All right, and this is a natural language API. The intent is not to talk about natural language, but the intent is to show the nature of software as a service. So here's a very simple sentence, right? And maybe I am talking. So here's a sentence, and I'm just gonna click on it, right? Yeah, I'm not a robot for sure. And what it's gonna do is it will give me results. This is solving an NLP problem. However, and we'll probably talk about this some other day if that's a topic you guys are interested in. Hey, by the way, if any of you are not subscribed to the channel, please subscribe to the channel. It would mean a lot. And if there's a topic that you want me to talk about, please leave that in the comments so that I can probably prepare for it and talk about in the next streams. All right. So this is as a service. This is software as a service. I'm consuming a simple software, which is NLP, which is around NLP, and I'm able to just use it out of the box. Out of this sentence, I can see straight about some sort of a sentiment, right? Although there's practically nothing about sentiment here. Maybe I'll add, and I am very, very happy. All right. And then there's probably, if you would see, hopefully the sentiment changes. Yeah, you see, it's almost talking about very positive, 0.9, right? And it is saying all of these few words, which we'll worry about sometime later, right? Then it's also showing me syntax. So basically what is happening here is that we are looking at a lot of functionalities and we are consuming them, all right? So that's software as a service. Just to demonstrate the same idea once again over probably a text. So SaaS, let's say a function, any function that a user consumes. Usually he pays for the function and not for infra. So in a SaaS model, you are not charging for infrastructure. You are typically charging for the service. Needless to say that the service charge incorporates the infrastructure consumption that any organization is doing. But for the user, he's just paying for the function. Let's say there's a company X and they have a functionality, whatever, YouTube or just the API that we saw. Right? This is what is SaaS. This is what software as a service means. And there can be a very long discussion about how to build a software as a service, and maybe that could be a topic we can talk next time if that interests you guys. All right. Now coming back to the thought, right? Platform as a service. And we'll now log into DigitalOcean Cloud, which is, if you guys have been following me, you would know that one of my favorites. The reason I like these guys is that they are relatively making my life very easy. It's easy on the what do we say? It's easy on the pockets, and it's extremely straightforward for me to start using. Right? Let's not go here. Okay, now we have landed on a console, right? And I want to demonstrate the ability of platform as a service. So DigitalOcean has a system called apps, right? And here, what you can very easily do is deploy your applications. So the goal, my bad, I'm showing something else. So the way I ended up here is this is DigitalOcean Cloud, and yeah, this is DigitalOcean Cloud, and I've just clicked on apps. And apps is DigitalOcean's way of talking about PaaS, right? Platform as a service. And you just focus on code, not servers. And if I create an app, although I don't have a demo example set up, but this should be relatively straightforward. So you just select anything, probably let's take DigitalOcean container registry because that's probably easiest. Okay, nothing is available. We'll go back. I will probably connect to my GitHub again. Now it can connect to a couple of places. It can connect to your individual GitHub. It can connect to GitLab. It can connect to probably, it can connect to multitude of places. We just, so I'm just authentic. Oh, this is not good. Allow me a while to fix this. There must have been a change in permissions or things which is not allowing some sort of a global access for DigitalOcean, but I think we are through that. However, I don't know if there's something that it is still not there. Let's look at Docker Hub. We'll go to Docker Hub. Docker Hub, for people who don't know, is a registry. It's a place. We'll just pick Nginx for the lack of less option, and I'm gonna say repository slash name, hub name. Nginx. Okay. Nginx is a simple web server. What is the repository name here? Wow, this is not good. Allow me a second to set this up, guys. Till then, if somebody has a question, feel free to shoot. I am not sure why this is not working. It usually works pretty well. I'm gonna try to run this through documentation. It's still not connecting, and neither it is allowing to pick from Docker Hub. There's some sort of permission issue that I have, but probably what I'll do is I'll just walk you guys through an example setup so that you don't miss out what I'm trying to see. So this works. I've tried this couple of times before. Is there some permission issue? Most likely with my GitHub, because I was playing with it some time back. So what this allows you to do is you can, once you get access to your GitHub, right, you will get list of it like this, right? You'll get a lot of different sort of apps, React apps, Hue apps, PHP apps, Java app, Python apps, any of the apps, right? And it will automatically determine, and you will be able to set the scaling of it. You'll be able to set the sizes that you want to control, like how big or how small you want it to get. And that's it, right? Once you have that, you'll be able to access your application over an endpoint, and you can also scale it up and down depending on your need. It's that easy. It's literally just 4 steps. If this was working, I would have had better luck, but neither it is connecting to existing container registry or not even giving me any trials. Okay, great. I should have clicked here. These are some demo apps. So we'll just take Python for instance. Thank you, good Lord. And it's just giving me certain parameters for Python app, and it will ask you to pick the source directly. It will ask you to give the type. And there could be a couple of options like a static website, worker app, where in case you're running some kind of a backend job or something. And if you can want to change the source directory, you can change that too. Close. And then a couple of other settings, right? Which is the run command and build command and environment variables and request. You can add a database, doesn't really matter where the database is. And click on next. Sample, select the region. I am selecting Bangalore because they are relatively close. We have given it name. Sample application test. Yeah. The name has to be a unique name, and that's it. Yeah. So you finalize and launch. This will not allow me to do a starter or a free plan simply because it's not a static website. But if you select static before and you really don't have a lot of dynamic content, for example, you want to host your own individual portfolio, this is great. This will give you automatic HTTPS. You can have your custom domain, so all you need is your HTML files or your portfolio sitting in GitHub. You can connect here and it will give you an amazing portfolio website. I used to have one, but I scraped it off some time back, and that's causing me this heartache. So then there's a basic plan and then there's a pro plan, which kind of just gives you a much higher scale and things. So this effectively is PaaS. Now to go back and just write out what I've talked in the last few minutes. Right. Okay. Next. All right. So PaaS, right? Platform. What is the platform? The whole cloud kinds of becomes your platform, right? All you worry about is your app. Well, also data, but that's it. You don't have to worry about things like let's say OSS. You don't have to worry about let's say deployments. Also scale is taken care to some extent. Well, it is very debatable, and different cloud providers have a lot of different kind of options to do the same thing, for which is to do a PaaS. Like there's a lot of PaaS services out there. Most of the cloud providers are trying to improve their PaaS game because there's very less to improve in the infrastructure as a service game, right? And that's what effectively is PaaS. If I talk about other cloud providers, maybe what I'll do is I will show you Azure PaaS. And Azure PaaS as a service. There's a web app concept. Wait, I'll just search Azure web app. So web app service is an Azure web app where you can just deploy a web application as a container, and this is a PaaS. This has great integration. This has great support for creation of things like WordPress. So and has a lot of auto scaling and load balancing built in. You do not need to worry about any sort of what do we say, infrastructure related stuff. You don't have to worry about framework selections, and it supports both Windows and Linux. You can get your application could be anything: .NET, Java, Node, PHP, Python, .NET Core, again Ruby, whatever you have, it has options to it, and it provides a lot of interesting options too. Like for example, getting insights and taking care of scale on demand. This is a great service if you want to kind of work towards building a web app. Azure PaaS for machine learning. Let's look at for AWS. And for AWS, you have SageMaker, which is what I talked to last time. If you guys want to check out that, please look at last week's live stream. I was talking about SageMaker in great length. Also, there's another popular YouTuber, Krish Nayak. He has done an amazing session on AWS SageMaker. Do check his series out. His name is Krish Nayak. If you just YouTube, you'll be able to figure out. You'll just search on it, right? And this again tool is for machine learning PaaS, but platform as a service is not just machine learning. You can do it for almost achieving any kind of goals. You want to have web apps, you want to have APIs, you want to have backends. All of that is available as a PaaS offering, right? So here, if I just go back to my fundamental diagram, platform as a service, runtime, middleware, OS, virtualization, server, storage, networking. Everything is managed by the provider. You don't worry about anything at all. Quite literally, all you worry about is building your application. However, the payment plans would be different. The pricing would be kind of inclusive of infrastructure. So please pay very strong attention to documentation and pricing before using PaaS. PaaS offerings are, while easy, it has been my experience that they can end up being costly if you don't pay attention to the way they are pricing it. All right. Now, finally, we'll move on to the last leg of the stream where we talk about infrastructure as a service. And I'll just grab a little bit water. Thank you. And infrastructure as a service really is goes all out, right? It's everything that you have studied in probably college and probably a little more. And except the virtualization, and in some options, you actually even can control that. You can probably get dedicated machines if you get into a larger setup. But infrastructure service is at the base of it. For example, if I look at current the way I'm live streaming this, YouTube becomes software as a service. I'm using an app called Melon app, which is sitting between me and YouTube and broadcasting to YouTube. So that becomes a platform as a service. And finally, everything below it is all infrastructure. So we'll look at what is infrastructure. And as I talked before, right, as I was probably talking here, this part, compute disk networking virtualization. That's the key for learning cloud, right? Now, if you pay very strong attention to the left-hand options, there's droplets, which is compute, volumes and databases. Volumes are, okay, why is it so slow? Volumes are storages. Databases are also storages. Spaces are also storages. So three of the options are for different types of storages. Databases, relational, non-relational. Volumes are more for storing your disks kind of a setup. Spaces are object storages, in this case, very similar to S3. Container registry and actually images, that is also storages, but you're trying to store a different kind of thing. You're trying to store container images there. For containers and Kubernetes, we'll probably talk about in a later session because that's just a world in itself, trying to talk about virtualization, Docker, Kubernetes, and all that. So compute, storages, and networking. Virtualization is managed by the provider here. If you see, so virtualization is managed by the provider. Now we'll see how the stack works. And in networking, as I mentioned, there's a lot of options: domains, IP, VPC, firewalls, all sorts of things. There's a last option which is called monitoring. Monitoring implies that once you have built so much, right, you would want to see where you're headed. You would want to see how things are working out for you. You would want to notice if something has failed, if your app is crashing, and things like that. So that's monitoring, right? Monitoring is one of the most critical part. Now, DigitalOcean allows me to teach this very lightly in a very simple way. However, if you go on to any other cloud provider like Azure or AWS, you can find what these services are called there. Do not be boggled down by the number of services. Start with small and then make your world above. So we'll go to droplets and quickly show you how to create a machine, maybe even create it if they don't bill me. All right, so going back to images again, OS is managed by you, you manage. So if you see, you have lots of options of OSs. I'm just going to select basic, which is Ubuntu. And Ubuntu is what I'm going to just stick to, but you can obviously select FreeBSD, Fedora, Debian, CentOS, tons of options. You can even bring your own custom images if you want. You can just add an image and it will allow you to set up your own images and upload and all that. But we are not going to be doing that or trying to do that today. All right. Then let's look at it and choose a plan. So you have a shared plan, which is basic. Then you select some CPU options. Again, if you have not watched my previous DigitalOcean videos, I have covered this in slightly more detail regarding the pricing, regarding the options, what to choose and when. However, for all general practical purposes, academic purposes, just select basic, start with small. This will give you 1 GB of RAM and 1 CPU, which is more than enough to practice Linux. If your use cases are higher, if you're somebody who's just always opt for machine learning and stuff, then you need to go up and you need to pay more for it. So that's the OS part. And then you select the plan, which is the pricing, the compute, which is, as I was mentioning in my nodes, if you pay attention to this part, CPU and memory. Okay, so we are talking about CPU and memory, which is what you are selecting here. CPU, memory, and obviously disk, right? Disks are mandatory. Then you can add block storage. Block storages are just disks for your machines, like more storages for your machine. And then you select the data center region where in the world you would want to have these machines. Now remember, these are virtual machines and are enabled by virtualization. I'm just selecting the one closest to me in Bangalore. I can create a password. I'll just say BCD blah 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 something. Okay, now. Oh no, this is relentless. All right. You can enable a couple of more options. You can enable monitoring. You can enable IPv6 networking, which is more of an advanced networking. You can have your user data persisted and things like that, which is kind of, again, slightly advanced. And you can enable backups, which is at 20% of the price, depending on what you select. Now, please remember that this price is for the month. So they're going to charge you $5 for the month. If you think about it, it's like crazy cheap. If you want to look at more like a general purpose machine with a 16 GB and 4 core machine, it will cost you $120. And with an SSD, right? Now, if you just, this is more than enough for almost anybody trying to do anything, and this is like 7,000. But in reality, if you use cloud judiciously, your use case should not be more than a couple of hours. So probably you should not be spending more than $20-$30, which is a very good deal if you want to play around and learn high performance compute. If you don't have a laptop, let's say you are learning data science and you don't have a powerful laptop, in the beginning, in your trial runs, in your learning period, it is very great. It's actually a great idea to just rent out something on cloud, use it, and it will teach you more than you thought you would learn. And then you can probably get on to buying machines and all that. Finally, all you do is just say create, and it's going to create a machine for you. All right. Once it creates a machine, it usually takes a while, which is why I'm not creating it. Again, check out my previous video for seeing about how to create and stuff like this. And once you create it, will show you a machine which is created under a droplets tag, and you'll be able to work with it. Right. Apart from this, just moving on. So we have talked about compute. We have talked about compute. We've talked about storages as well. Now we'll talk about some sort of a database stuff. So you can create a database here. Multitude of options. Again, you can create MongoDB, which is a NoSQL, or you can create a Postgres, MySQL, or Redis, or you can actually have all of them, right? Depending on the different kind of use cases you have. Relatively easy setup on DigitalOcean. It probably takes you about 30 minutes to an hour. If you are probably absolutely new, you should be able to get up and running in, let's say, a week if you practice it. Great free tier. Probably if any of you are interested, let me just share that. There's a free credit available for most of the people. Let me just check out where is the referral page. Does it allows yeah, you can just check this link. This gives you some free credit. I don't know. It used to be $100. It says it still is. I've never actually tried it. I've probably a lot of people have kind of taken up me on this. Like 96 people have clicked on it, and people have signed up is almost 20. But I've actually never earned money from the referral. But please do use this to practice DigitalOcean Cloud and practice cloud in general. All right. So that was databases. Going back to databases tab. This is where we were. You can just work with it. You can create any type of database you want. And again, same, select the data center, select networking, and create a database cluster, right? So that's pretty much it, what it needs to what it takes to get up and running on cloud. And you probably, if you are here listening, probably would have understood a bit in 30 minutes, right? And if you can see that this is not relatively difficult, it's actually an easy thing. So I would highly encourage you guys to go practice it out, and just spend a little bit time with it, and you'll maybe learn new stuff. And finally, just trying to go out back on the diagram. This is what constitutes stuff on cloud, right? You have certain things on premises, you have certain things as infrastructure as a code, platform as a service, and software as a service. Finally, going back to what we talked about, you have cloud. Cloud comprises of compute, which is effectively servers, and you select CPU and memory. Then you have storage, which is like disks, databases, NoSQL, SQL stuff. Then you worry about networking, and in networking, there's a lot of things to talk about, right? You worry about IP addresses, load balancers, and things like that. So these are the four things that you worry about effectively in cloud, which is compute, disk, networking, and virtualization. And once you start practicing stuff, right, it should make your life a relatively easier. So that's pretty much what I wanted to talk about on cloud. Feel free to throw in questions if you have any. Just put it in the chat, or if you want to join the stream, feel free to ask, and I'll send you a link right away. At the same time, if you're somebody who have not subscribed to my channel, please do subscribe. The button should be, I don't know where, but please subscribe to the channel, like the stream, do leave a comment about topics that you want to listen around, right? And I'll try to get that again. If you want to personally contact me, uh, check out my maybe Quora or blog, and you should be able to reach out to me. So this is my blog, and this is my Quora account. And yeah, just try to reach out to me on any of these, and I should be able to respond back. With that, that's yeah, this is my Quora page. We have recently started. We're trying to get on with it, and trying to post stuff about data science, cloud, and stuff. And this is my blog, where I've been blogging for a relatively long time. There's tons of content here. If you want to learn Git, you have Git stuff here, which is very, very important for people. If you want to learn data science related stuff, there's a lot of stuff on deployment, how to make a web app, how to deploy on containers, and things like that. So that's pretty much it for today. Please do subscribe to the channel again. And with that, I will just thank you guys. Thank you for listening in. Thank you for checking in. Bye bye, everyone. Have a great rest of the week. Stay happy, stay smiling. Bye bye. Thank you.